Morning, friends. Welcome back to the next lecture of satellite communication. I hope my screen or my slide is visible to you. So in the previous lecture, what we discussed, different terminologies which are related to satellite communication. Suppose this is the Earth and a satellite is rotating around the Earth. And this particular line, which is represented by the dotted green color line, this represents the equatorial line. And similarly, the other side of your planet, other side of the Earth, you have the same equatorial line, which will be like this dotted, it will be like this. Okay, so which I can draw like this. And drawings might not be accurate, but make an assumption. So this is the equatorial line, and this particular thing represents the equatorial plane. Okay, that means if you horizontally make a cross section, okay, along the equatorial line, so that particular plane we call it as equatorial plane. And henceforth we also have discussed what is the subsatellite point. If you make a line joining from the center of the Earth to the satellite, and the point, this line, when it intersects any point on the surface of the Earth, so that particular point is called subsatellite point. And when we say the location of satellites, the location of the satellite can be obtained from the location of the subsatellite point. So how we can find the satellite location by the latitude and longitude of the subsatellite point. Okay, and we discussed that. So this equator, it is having 0° latitude, and towards north it will go up to 90° north, towards south it will go also 90° south. Similarly, this line represents your 0° longitude, that is which is passing through the Greenwich, and towards east you will have 180° longitude. Similarly, towards west you will have 180° longitude. Then we discuss what is called nadir, what is called zenith. Okay, and suppose one satellite, the name of the satellite is GSAT-3, and it is located at 83° east. So it is given 83° east. That means the longitude is given, but the latitude is not given. So latitude is not given. That means it have to be assumed that it is located at 0° latitude point. Okay, so 0° latitude means that is on the equatorial plane. The satellite is located on the equatorial plane, and the longitude is 83° east. Okay, so in that case, the where, can you tell me where the subsatellite point will lie? What is the location of the subsatellite point? If the location of satellite is given, so what is the location of the subsatellite point? The location of subsatellite point will be exactly the same as the location of the satellite, because we say I said that we find the location of the satellite from the subsatellite point. Okay, based on what is the latitude and longitude of subsatellite point, based on that we represent the location of the satellite. Understood? So if it is given the satellite is located at this particular coordinate, so it is understood that the subsatellite point is exactly here. So in this case, the in this case, your subsatellite point will be where? It will be at 0° latitude and 83° east. So this equatorial line represents 0° latitude. Okay, and this horizontal line represents the longitude. So that is the 0 degree longitude. This represents 0 degree latitude. And your longitude values will keep on increasing like this. And it will go backside 180 degree. In backside, it will cover 180 degree. Similarly, in this side also, it will go like this. Okay, it will here 180 degree. So total will be 360 degree. So this side, it will be east, and this side, it will be west. So it has been said the location is 83 degree east. So 83 degree east means somewhere this is called the 90 degree longitude, because this point is 0 degree, this point will be 90 degree, and backside exactly here it will be 180 degree. So 83 degree will lie somewhere, which I will represent by a different color. So it will be somewhere 83 degree will be somewhere here. That is the longitude. So 83 degree longitude line will be like this. My drawing again is not perfect, but as you, this is the longitude line, that is 83 degree east. East means this side. Okay, and 0 degree latitude means the red color, this red or this dotted blue color line. So they intersect at this point. So the satellite, the sub-satellite point will be here. This is the location of the sub-satellite point. So where the satellite will be located, now you make a line joining between that, make a line. Okay. And this is the location of your satellite. So here from this to this distance is how much? It will be roughly about 36,000 kilometer. Why I have taken 36,000 kilometer? Why not 1,000? Why not 10 or 20,000? Because the satellite is located on the equatorial plane. So this satellite is a geostationary Earth orbit satellite, or that is called geostationary satellite. The orbit is called geostationary Earth orbit, or the satellite is called GEO satellite. That means geostationary Earth orbit satellite. So it is located at a height of 36,000 kilometers from the surface of the Earth. Okay, so now the conclusion is that GSAT-3 is a geostationary satellite. Okay, since if any satellite, if the latitude is not given, only the longitude is given, so make it, it is clearly, it has said that it is a geostationary satellite. No need to mention, you can understand, because it is present at 0 degree latitude. Okay. So this is what I said. And this is the example which we had taken in previous day. And this also we have discussed the tracing, and we also have discussed what is elevation and what is the elevation angle and what is the azimuthal angle. And then we had taken one a new topic, that means how we can find the range and look angle of the satellite. So when it is said the range of the satellite, what do you mean by range? So the range we calculate between two different points. So one point is the ground station, another point is the satellite. Okay, so do not be in misconcept that range does mean by the distance in between the sub-satellite point to the satellite. So it is range does not mean the distance from sub-satellite point to satellite. No, that is the wrong, because we know that if the satellite is a geostationary satellite, then by default this distance from SSP or sub-satellite point to satellite is 36,000 by default. So what we are going to find out here, because it is already prefixed, so no need to find out this distance. So the range does mean by here, the range means what is the distance the satellite is located from the ground station. Okay, because the communication is being established between the ground station to the satellite. They are communicating with each other. So we are going to find out that at what distance or at what kilometer range the satellite and the ground station they are located. What is the distance in between them? So that is the range we are going to calculate here. Second thing, it is the look angle. Okay, so look angle means in look angle what we are going to calculate, that what will be the coverage. Suppose one satellite is located here, so on the surface of the earth how much portion the satellite covers, how much portion the satellite covers. That means how much geographical area the satellite can communicate, or how much portions on the surface of the earth can be within the coverage of the satellite. Okay, so that is the look angle we are going to calculate. So we have two different stages. In the first stage, we will calculate the distance between the ground station to the satellite. In the second stage, we will calculate the look angle. That means how much portion on the surface of the earth will be in the coverage of satellite. Understood? Because suppose assume that this point to this point, this point to this point is under the coverage of the satellite. That means any ground station which is present within this range, they can communicate with the satellite, and satellite also can communicate with those ground station. If any ground station is located somewhere here, then this ground station will not be able to communicate with the satellite. So in the second phase, we are going to find out that how much portion on the surface of the earth will be in the coverage of the satellite. So to do that, we have represented some symbols where RE that represents the earth radius, H represents the orbital height. So orbital height means it is the distance from the subsatellite point to the satellite. And if you include the radius of the earth, so this distance that is denoted by a symbol R subscript S. So this represents the orbital height of the satellite. There is a difference in between orbital height of satellite and height of satellite or altitude of satellite. So they are not similar. Orbital height of the satellite means the satellite rotates in its orbit. So what is the radius of that orbit? So that is the orbital height of the satellite. Okay, but when we talk about the height of the satellite, or when we talk about the altitude of the satellite, that we calculate from the sub-satellite point. So how much distance the satellite is located from the sub-satellite point. So that gives us the altitude of the satellite. Okay, now understood the two terminologies. So D is the distance we are looking for. It is the distance that is the satellite range. So we see here D represents the satellite length. So which is the uh, concerned thing for us. That means we are going to find out this thing. And L is small L represents the longitude of the earth station. Okay, you see this is this vertical line represents 0° longitude. This represents 0° longitude, and this as you go towards east, the longitude will increase, and at this point you will reach at a point that is 90° longitude east. Similarly, in towards west side, you will reach at a point 90° west longitude. Okay, and similarly, this line, which are horizontal lines. Okay, you can see one horizontal line, this one. So this is called the 0° latitude. Similarly, in vertical, there will be many horizontal lines. Here also, you will have many horizontal lines like this. Okay, so this is the latitude, this is the latitude, and finally you will reach at 90° latitude south. Okay. Above also in north, you will have many latitude like this. Okay. So now next term is capital LE. Capital LE represents the latitude of Earth station. So here Earth station is located here. So the latitude means at what latitude it is located. Okay, that means this angle in the north. And then small ls represents the longitude of subsatellite point. That means this is the subsatellite point at which longitude the subsatellite point is located. And similarly, the capital LS represents the latitude of subsatellite point. That means at what latitude it is located. If you make a line, means horizontal line, so that is the latitude of subsatellite point. Okay, so these are different symbols we have used. Now, in addition to those symbols, so we have taken some angles. So one angle is called gamma. Okay, so this is one angle. Another gamma is angle is called psi. Psi is this angle. Okay, and in previously I also told you that this angle psi, you can see, suppose this is the Earth. Assume this is the Earth. This is the center of the Earth, and this is the consider this one is your ground station. Okay, this one is the ground station, and the satellite is located here. Okay, this is the location of the satellite. Now, if you make a line joining between the center of the Earth to the satellite, so this point is the soft satellite point. And from ground station to satellite, this distance is d. So we are looking for the value of d in this particular lecture. And if we make a line joining between the center of the Earth to any surface, any point on the surface of the Earth, that is nothing but your radius of the Earth, small r. Okay, so this is the angle which I am talking about. Okay, this particular angle we have represented by a symbol that is called psi over here. Understood the thing? Now let us analyze this angle psi in deeply by drawing one tangent at this particular point. That point is your ground station. So at this point, I will draw one tangent. So if I draw a tangent, the tangent will be like this, such that this angle will become 90 degree. Okay, so the total angle we have represented by psi, and out of that total angle psi, this angle is 90 degree. And what about this angle? So this angle is called the elevation angle. So we can represent the angle psi is equal to 90 degree plus elevation angle. Hope I have explained it in more simpler way for you, I think. If any doubt, you can ask me, because in this, in the previous, diagram, yeah, this one, if you see, this represents the elevation angle. So this, suppose assume that this is the surface of the Earth, at what elevation the satellite is located. So hence, that is what we are considering. So this angle is, I will use a different color for the understanding this much. So this angle is your elevation angle. So we can write the angle psi as the summation of 90 degree plus elevation. Okay. Now in the triangle ACC, I can write this square of this distance is equal to r square plus rs square. This is the, by applying the cosine law to any triangle ACC. We can write like this. Okay. Now we also can write in this triangle, this one also can be written. That means any side of the triangle divided by the sine of the angle in front of that side is equal to any other side of that triangle divided by the sine of the angle in front of that. Hence, D is one side of the triangle. D divided by sine of gamma is equal to RS. RS means C to S distance is RS. This point center of the earth is C. To the Saturns we have represented by RS, which is one side of the triangle SEC, and the angle in front of this side RS is your psi. So RS divided by sine of psi. So this equality we can make in any triangle. Correct? And in previously, if you see this angle, I have written psi is equal to 90 degree plus elevation. So I can write sine psi is equal to sine of 90 degree plus elevation. So what is sine 90 degree plus theta? So sine 90 degree plus theta is nothing but cos theta. So this one I can write sine psi is equal to cos elevation. So hence that is what has been written in this case, sine psi is equal to cos elevation. Now I can replace the value of sine psi in this equation. So this equation will become d divided by sine gamma is equal to Rs divided by cos elevation. Now by doing the cross multiplication, I can write cos elevation is equal to Rs into sine gamma divided by d. So this is what I have written, Rs into sine gamma divided by d. So that is the value of cos elevation. All right. Now just go back to the previous page and let us find out, because we have to find out what is Rs by d. See here, in this slide also I can write, here I am writing, it is Rs multiplied by sine gamma divided by d. I can write it like this, sine gamma divided by d by Rs. This I can write. So let me find out what is the value of d by Rs. So if I can obtain this value, which can be replaced in the denominator, that I will obtain from here. What we are looking for? We are looking for the value that is d by Rs, how much it will be. So this is the thing we are going to find out. Here the value of d square is given. So let me divide the left hand side by Rs square and the right hand side by Rs square. So in the left hand side, I will have d square divided by Rs square, or that is equal to d by Rs whole square, that equal to, in the right hand side, it will be Re square divided by Rs square, Re square divided by Rs square plus, this is Rs square, this is Rs square will cancel, plus 1, then minus. Here you have one Rs and here this square. So you have 2Re divided by Rs multiplied by cos gamma, multiplied by cos gamma. So d by Rs square is this much. If you want to find only the value of d by Rs, then it will be square root of that. So now we obtained the value of d by Rs. So cos elevation is nothing but sine gamma divided by d by Rs that we have obtained in the previous slide. So using that value of d by Rs, I have written. So this is the value of d by Rs which I have replaced from the previous slide. So I got the value of cos elevation is equal to this much. Now, if you look at this expression, what are the unknown terms are there? Gamma is unknown. RE, RS, if you consider a satellite which is geostationary Earth orbit satellite, for that RE is not related to the satellite because it is the radius of the Earth, which is 6,357 or something around that. That is the radius of the Earth. RS is the orbital height of the satellite, which is around 41,000 something. You see here, I have taken some approximate value of radius of the Earth, and I have taken approximate value of orbital height of the satellite. Using those values, I can obtain the cos elevation, this parameter, like this. So what is unknown? Only unknown is gamma. If I can find out the value of gamma, then only I can able to obtain the value of cos elevation. So my objective is to find out the gamma value. So once gamma can be obtained, then use the value of gamma in this equation and cos elevation you can find out. And once you can find out the cos elevation, then once you can find out cos elevation, you see here sin psi is equal to cos elevation. So here in place of sin psi, you can write cos elevation, and cos elevation you already calculated. Okay, gamma, that also you have calculated. RS, or geostationary Earth orbit satellite, the value of RS is, we have considered it how much? 42,000, this one. Now, only unknown will be D, so which can be easily calculated. So the target is how we can calculate the value of gamma. So once the gamma value will be in our hand, then we can find out the range. Okay, so this can be obtained. So let us go to calculate the gamma value. So in order to calculate a gamma value, you have to go for an expression that is we obtain by using spherical triangle law of cosine. So you have to remember this. It is this equation has been obtained from the spherical triangle law of cosine. So cos gamma is equal to cos LE into cos LS multiplied with cos LS minus LE plus sin LS into sin LE. You know what is capital LE? Capital LE is the latitude of the Earth station. Capital LS is the latitude of subsatellite point. Small ls is the longitude of subsatellite point. Small le is the longitude of subsatellite point. Capital LS is the latitude of subsatellite point, and capital LE is again the latitude of Earth station. Okay. Now I will ask a very simple question, and you can be able to answer by using this. Suppose my question is, suppose the satellite is geostationary Earth orbit satellite. Okay, geostationary Earth orbit satellite or geostationary satellite. So what will be the expression of cos gamma? What I have said, the satellite is geostationary Earth orbit satellite. That means the satellite is located at 0° latitude. Okay, so when I said the satellite is located at 0° latitude, then what I am indirectly what I am telling, the sub-satellite point is located at 0° latitude. Okay, that means the latitude of sub-satellite point, latitude of sub-satellite point is 0 degree. All right. So what is known? LS is equal to 0 degree. So cos of 0, it will become 1. Okay. Similarly, here sine of 0, it will be 0. So 0 multiplied by anything, this particular term will become 0. But this one is 1 because cos of 0 is 1. So for GSO or geosynchronous orbit, LS is 0. So let me correct, it is not GSO, it is GEO, because all GSOs are not GEO. That means all geosynchronous satellites are not rotating in equatorial plane. Okay. So for GEO satellite, LS is 0. And for that, if you put LS, this will become 1. So it will be cos LE into cos LS minus LE. So this is what we obtained. But this particular term, it will become 0. So that's why that particular term is not present. Now, where we have landed now? We have landed somewhere in an equation. This equation, looking at this equation, can you tell me that now at this stage, can you find out the value of gamma? The answer is yes. If the location of the sub-satellite point will be given, if the location of the Earth station will be given, then we can find out the value of gamma. Okay, so everything matters with the at what location the satellite is there and at what location the ground station is there. So once the latitude, longitude of the satellite and latitude, longitude of the ground station will be known to us, we can easily find out this gamma value. Okay, so once we obtain the value of gamma, we can find out sine gamma and we can find out cos gamma here. So cos elevation will be known to us. So once cos elevation will be known, yeah, here you see cos elevation is nothing but sine psi. So sine psi will be known. Gamma we already have obtained. So only unknown will be d. So d we can find out. So this is how we can able to find out the distance in between the ground station, which is communicating with the satellite, and the satellite. So how much distance the satellite is located from the ground station. That means when we are transmitting any signal, we mean the sense when the ground station is transmitting on some information or the satellite is transmitting some information to ground station, then that information covers how much distance. So that is given by d in this calculation, so which we can find out. Okay, so could you follow this explanation? So in this case, we saw that how to find out the range. So range in the sense it is the distance in between the ground station to the satellite. Okay. So let us take an example, quick example, and try to find out. So it is given that INSAT satellite is the point. INSAT at 83 degree east and 0 degree north, Earth station insert at 83 degree east and 0 degree north. Earth station at somewhere in Kharagpur. It is in 78 degree east and 22 degree north. Find Earth station elevation angle to insert. Okay. So now what is given? The latitude and longitude of the satellite is given. INSAT is a satellite. Its latitude and longitude given. And there is a ground station, or that is called the Earth station, which is communicating with the satellite. And the latitude and longitude of the ground station is also given. Okay, so can you find out at what point your ground station and at what point your sub-satellite point is there. Can you find out that? Let us do it. A very conceptual thing it is. Okay, so this is your Earth, and this is your Earth, and this particular line, it represents what? What it represents? 0° latitude, and this line represents 0° longitude. Okay, this line represents 0° longitude, and this point represents the center of the Earth. This is the center of the Earth. Okay, so let us locate the satellite where it is located. See, the latitude, the longitude is in east. East means the value is in longitude. So 83° east. So 83° east. Suppose 83° east and 0° north. So 0° north means you can close your eyes and tell me the satellite is an GEO satellite. The satellite is a geostationary Earth orbit satellite, because that's why the latitude is 0°. And if a satellite is a GEO satellite, so what is the location of sub-satellite point? Where the sub-satellite point will remain? The sub-satellite point will lie on the equator, because all the GEO satellite or geostationary Earth orbit satellite, their orbital plane is having 0° inclination with the equatorial plane. Okay, so the GEO satellites, they are moving on the above the equator, exactly above the equator. All GEO satellites are rotating. So if you make a line joining between the center of the Earth to the satellite, then that will pass through the equator, somewhere in the equator. So either it will pass here, 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 it will pass here. Any point on the equator, the sub-satellite point will pass through. Okay, but now look at this. What is the longitude given? 83° east. So it will not pass anywhere. It will pass at a point which is 83° east longitude. So suppose this point is 83° east longitude. Longitude means this line, vertical line. So this is the location of your sub-satellite point. This is the location of your sub-satellite point. Understood? Now you make a line joining the center of the Earth to the sub-satellite point, and you extend it towards this direction. And if you go up to a distance of 41,000 kilometers from the center of the Earth, or around 36,000 kilometers from the SSP point, then you will reach exactly at the satellite point. Okay, so hence we obtain the location of the sub-satellite point, and let us look at where Kharagpur is present. So what is the longitude of Kharagpur given? 78° east. Okay, the longitude here, the longitude is 83. So here the longitude is 78. That means Kharagpur is located towards which direction of the satellite? The longitude of Kharagpur is given 78° east, but the longitude of satellite is 83° east. So in which direction the Kharagpur is located with respect to the satellite? The Kharagpur will be located towards west. With respect to the satellite, it will be located towards west, not with respect to the 0° longitude, because the Kharagpur is located 78° east. So suppose this point is what? This point is 83° east. So 78° east means it will come here. It will come here. So that line, that longitude line, it will pass like this, but also latitude is given. That means the Kharagpur is not located here. Kharagpur is not lying on the equator. At what latitude? It is present at 22° north. So 22° latitude. So 22° latitude means, so this is suppose 22° latitude line. So this point, your Kharagpur is there. So this is the point where Kharagpur this is the location of the Kharagpur, and this is the location of the subsatellite point. So at Kharagpur, you have a earth station or ground station. Your ground station is at Kharagpur, which is here, and this is the subsatellite point. Okay, the question is to find the earth station elevation angle to insert. So we have to find out what is the elevation angle. So this is pictorially I have represented, means at what latitude, longitude the satellite and the ground station are present. Now by using the given equation, which equation? This equation. Okay, you use this equation because all latitude and longitudes are given. So from this you can find out the value of cos gamma, and from cos gamma you can find out gamma and put the value of gamma here, and you can find out the elevation angle. So that is what we are doing here. So we have put the value of that what is given, cos LE cos LS cos LE capital LE into cos capital LS into cos LS minus LE cos, this is small ls minus small LE, then sin LS sin LE plus sin LS into sin LE. Okay, so this is the equation of cos gamma. Okay, so what is LE? We know LE is the latitude of earth station, or yeah, this is latitude of earth station, which is located at Kharagpur. So in this case, what let me write down values. LE is the latitude of earth station. What is the value? Latitude is 22° north. 22° north. Then LS is the latitude of the subsatellite point or the satellite. So what is the latitude? It is 0°. So LS is equal to 0°. Then what is small LE? That is the longitude of earth station. Earth station is at Kharagpur. The longitude is 78°. It is 78°. Then LS, small LS, this is the longitude of your satellite. It is 83° east. So all values you have. Now you put this value over here to see. Capital LE 22. We have taken capital LE 22. Then capital LS 0. We have taken 0. Then a small ls minus small le. Small ls is 83. Small le is 78. So 83 minus 78. Okay. Then sin ls. Since ls is equal to 0, so sin of 0 is 0. So this particular term will become 0. So that's why I have not written that term. Okay, only this term is there. So if you find out, you will get 0.92. That is the value of cos gamma, and from that you can find out gamma is equal to cos inverse of 0.92. So which will be around 22.53. So we know cos elevation is equal to sine of gamma divided by this equation. Cos elevation is equal to sine of gamma divided by square root of 1.02 minus 0.3 cos gamma. Okay, so that we are using, and cos elevation we will get this. So what is elevation? Elevation angle, that is cos inverse this. So cos inverse of 0.515, it will give you 58.09 degree. Just look at this value what we are obtaining. The elevation is 58.9 degree, which is nearly equal to 60 degree angle. So suppose this is your earth. Consider this as the earth. Okay, so and this is somewhere your ground station is located, which is your DTH antenna. Assume the ground station is a DTH antenna. Okay, and as I have said, the GEO satellites, because we are concerned about INSAT. INSAT is a GEO satellite because its altitude is at 0 degree north. So in India, always the DTH antennas will be tilted little bit south, because the equator is India is present towards the north of equator. So that's why the GEO satellites, they are located towards southward direction from India. Okay, because the equator is towards south, so the satellites are present towards south. So that's why all DTH antenna, if you will see, they will be facing towards south. Then the question comes, how much tiltation we will do, whether it will be completely horizontally we will face it south, or it will be downward south, or how much angle we will make. So that angle is approximately 60 degree. Okay, so elevation angle is calculated like this. So this angle is the elevation angle. So when you install a DTH antenna, you make sure that that parabolic plate, it should make an angle of approximately 60 degree. The angle should be approximately 60 degree. So if you see, our country India is present in such a very good place, so that whenever we are constructing so much buildings, or even if some trees are present, still the television signal is not interrupted. Okay, because the antenna is looking at an elevation angle of 60 degree. Okay, but if you go towards north, that means for example you are going towards China, or you are going towards Russia, or towards Europe. Okay, therefore their geographical location is very much towards north. So in that case, their elevation angle will be lesser than the elevation angle at what we are getting in India. So their elevation angle will be very much less, because they are present in towards much more north than India. So their elevation angle will be very less. So for them, if there will be any object, any building present in front of the antenna, if any big tree will be present in front of that, then the signal quality will degrade. Okay, but in India, we are not facing that kind of problem. But we have to make sure that our DTH antenna should be make an elevation angle of 60 degree for a faithful communication between the satellite. Okay, so this is what we have calculated the range, and we have calculated the elevation angle, and we should able to get some concept that why does DTH antenna is facing towards south, and if it is facing towards south, what should be the elevation angle? That means how much bending we should make the DTH antenna so that we can communicate properly. So this is all about this lecture, and in the next lecture we will meet again, and we'll discuss the look angle. That means if a satellite is present, how much area the satellite covers. So that is the look angle, means how much portion the satellite can look from the top. That we will see in the next lecture. If you have any question, you can ask me.